Good afternoon, folks. Welcome to I/O. Hope you had an eventful day already, and it's an action-packed agenda in the next couple of days. My name is Srikanth Rajagopalan. I'm the product manager for Google PowerMeter, and over the next hour, I and Russ Heywood, the lead engineer, will give you a sense for what Google is trying to do in the energy information space with Google PowerMeter, where we are and what's ahead of us in terms of where we want to take the product. We're going to focus largely on the API side of things, but hopefully you'll get a good sense for where the product is and what's ahead. I've been on PowerMeter for the last year, been with Google about 5 years, been largely helping build the partnerships and the developer community around what we're trying to do with Google PowerMeter. And we'll be glad to talk to you all post this discussion also. Just a reminder, we have a live wave that goes with the session, so there will be notes, but also more importantly, there's a Q&A and questions that we're collecting on there. So if you have any points that you want to bring up, just bring it up there. And also, at the end of the talk, we'll also have mics here that we can use for any questions. So over the next 30-35 minutes, we're going to essentially give you a sense for where the product is, what actually it does. We're then going to have Russ do a little bit more of a deeper drill down into the design elements around how we build the product and how it influences the API, and then how do you actually go about using the API. Then we end up with the Q&A. So let me start by giving a quick overview of what PowerMeter is. As I said, it's a relatively new offering from Google. We've been at it for about 18 months, and we've been public about it for the last 12 months or so at this point. But the essential premise that we started the project on, and it started off as a 20% project internally, was we should have the same level of access to energy information for users as they have to anything else online. And we found as we got into the space that there is obviously some things that are happening which are moving in the general direction, but there is in general not the level of access and transparency, and more importantly, how users can get to this information and use it, and how they manage their household and their usage and energy consumption. The essential premise is that when you show something to somebody, that it makes them think about it, and we directly want to influence their behavior with it. So our goal is to really track and allow people to track how much they're using, use that to gain some insights and take action around how you can get better at energy. It's initially focused on electricity, but the platform and the capabilities allow us to obviously expand into other aspects of energy as we go forward. It's a completely online-based system, so it's something that we want to be able to provide to the users anytime, anywhere they want. And most importantly, it's a project of Google.org. Unlike other philanthropic initiatives, Google.org is unique in not just looking at projects from a funding and grant-making perspective, but really trying to figure out ways we can use Google's assets, whether it be infrastructure or engineering or IP that we have internally, and build interesting products that add value to the society. Being part of Google.org, it's also the case that we are not really measuring the success of PowerMeter in dollar terms or monetization metrics, but it's really being measured more in terms of the impact it's having. So for us, the success of the project is measured on how many users we are able to get on, how much are they saving in energy, and through energy savings, how much are they able to save in dollar terms. So the success of the project is more in terms of the impact of what the product makes people do, as opposed to any other metrics. And we want to obviously use that as a way to kind of drive some innovation in this space. So again, as I mentioned, one of the fundamental premises, awareness drives action. Some of you may be aware of this, and it's also been commonly cited, especially recently. there's this notion of a Prius Effect, which is if you show information and the data to a user, it makes them think about how they're using it and using the system or using the resource and actively learn and make an attempt to manage it better. This is just an example. A recent user who got on PowerMeter about 9 months back, and since then has dramatically reduced their consumption in their house by almost about 50%. On a more personal note, I had almost no idea about what I was using in my house. I would say, a very average consumer. I was a single-family home with a couple of kids. And we really don't have a good sense for what is it that we are trying to do, what we do at home. And since I've used PowerMeter and understood how I'm consuming energy in the house, I've actively learned to manage what I'm doing. I've upgraded my appliances as part of a recent remodeling, and I'm at this point saving about $500 a year, purely just on the basis of reduced electricity bills. So we do see and we do feel that there is very easy gains to be made here, and it's really important for us to get the data at a very high granularity with a lot of resolution and with low latency to the user, and that's what makes the information sticky and impactful. So I'll give you a sense for how PowerMeter works today. It's a residential solution at this point. It's largely focused on residential users because we also felt there are lots of solutions for commercial and industrial applications, but there is not really a good solution for the residential space. And in the residential context, there is a need to really drive more awareness to this information. Google's focus in providing PowerMeter has been largely to build the software platform and the framework to allow data to be sent in and being able to visualize by the user. But we can't do this without good sensors. And we are not directly building the sensors, but we are really working very closely with two main constituents who are responsible and who are required in a way to get to this information. The first route is what we are referring to here as the energy management devices, but there is a slew of partners that we are working with now. Some are public, and some that you'll start hearing about in the coming days and weeks, where they're really providing easy-to-install sensors, typically to measure the electricity consumption for the entire house, but also starting to look at ways to give you more localized sensors for plug-level data and appliance-level information. So these devices can be installed easily by the user, usually on their own, and sometimes with some assistance. And once the device is in the house and it's measuring, it can transmit the data to Google PowerMeter through a simple GData-based REST API. That assumes that the house has some basic broadband connectivity. The solution itself and the integration itself is lightweight enough, and we are not talking of sending gobblers of data, so it's not high bandwidth requirements, but it at least assumes that there is persistent connectivity so that we are able to get the data out to the data store that PowerMeter provides. The second route, and that's probably as important and probably a way for us to accelerate how we drive adoption, is through the utility route. Some of you may be familiar with the smart grid rollout, which is happening now in many parts of the country, as well as internationally. And it's all around deploying or having utilities rolling out what are known as smart meters, which are better and more sophisticated meters with usually some form of wireless and or radio connectivity. A major premise of smart meters has been to drive the rollout largely from the transmission and distribution requirements perspective, which is to allow the utilities to manage the transmission and monitoring of power consumption better. It has really not focused so much on how do you make that information also be available to the user. We feel that we can help access or provide that access, and we've been working very closely with a range of partners globally to allow them to take that information that is coming to them anyway for billing and also transmit it to Google PowerMeter. They do this, again, through the same GData-based REST API. And we essentially have a similar setup where you typically have a broadband or like using the backhaul network from the utility. They can provide the information at other users' behest and then make it available to the user. Once it's in the data store, the primary access to the information is through a browser. And I'll give a quick view of how we make that information available. But today, it's an iGoogle-based solution and also a standalone site, which you can access through a browser, whether it be at your house or on your phone and/or devices, and make that available to the user at no cost or at no charge. The third major participant in this picture is our application developers and probably a lot of the people that are in this audience. We feel that we really need to drive a lot more creative ways to make people understand the data. There is obviously lots of information coming in, but it can also be used in pretty creative and innovative ways. We feel we have some approaches that we want to try out ourselves, but more importantly, we want to make it possible and feasible for third-party application developers to be able to use this information and do interesting things with it. Again, we are hoping to be able to expose some of the APIs and over time expand the richness of these APIs, but the goal is really how do we make users understand the information and do something with it. Let me give a quick sense for the product. This is more a static slide, but this is my information coming from my house. I woke up pretty early today. But in any case, as I said, this is running today as an iGoogle gadget. You can click through, and it goes to a more full-fledged site where you can get more stats and information. But at a summary level, essentially, you can navigate over time. You can view the information at multiple granularity. I have a home energy management device installed that I installed in my house. So it's transmitting data in this case with about 15-minute latency and once every 15 minutes. So it's a very high resolution and low latency. So it allows me to see what I'm doing with almost no delay and lags. I can obviously navigate the data back and forth in time. I can also customize that. We feel that it's not just showing energy information, but you also need to make it visible to the user in terms that they can understand and relate to. So you can set like an approximate cost per unit of consumption, and we show the information in terms of approximately how much we anticipate you using based on the measurements that we're getting from the device. We also allow for some basic features around letting the user set targets for themselves and be able to say something like, I want to set a budget for myself in terms of how much I want to use, and use that to drive the behavior. And recently, about a couple of months back, we launched a social feature where we can now share this information with your friends and family. So I have it on as my primary. I'm the primary owner of the data in this case, and I see it on my iGoogle page, but I can obviously share it with and easily share it with anybody on my contacts list. And they get to see the same information, but on a more read-only basis on their iGoogle pages and the standalone site. That's primarily what I had in terms of a quick introduction. I want to hand it over to Russ now to give us the next level of detail in the product and what we are trying to do with the API.
OK.
Thanks, Russ.
Thanks, Srikanth. Can everybody hear me OK? Yes? I sound microphoned. Very good. What I want to talk to you about is sort of how we decided to build the system. So we have an API, but underneath the API is the core storage system, the presentation layer, the security system, et cetera. So I just wanted to walk you through kind of what we were thinking about when we built the product. I've been working on the product since the beginning. I checked in the first line of code. That was probably 18 months ago, I guess. And we've been adding partners, adding data, adding devices, and adding users ever since. So the first couple of kind of major bullet points that were important to us was that the system needed to have flexible data acquisition. So we wanted it to be really easy for a wide variety of data providers, like a device in your house or a smart appliance or a smart meter at a utility. They'll all have data in wildly different formats. They'll all have different kind of latency characteristics. Utilities sometimes want to send you, send us a chirp as soon as they have a piece of data. Other times they want to backhaul it and archive it and refine it and then send it in nightly. Sometimes they want to send in backdated historical data. Devices might also kind of have network dropouts and then need to recover and retry later. So it was important to us to allow the system to handle data in kind of random access, and you can write historical data, you can forward date data, you can backdate data. And of course, we wanted the service to always be available, which is why we built it on the same kind of Google infrastructure that keeps Gmail working and search working. Those are the same systems that we use. Another key sort of principle, I guess, that we built in from the very beginning was privacy. So we recognized that the smart grid, you've probably seen a lot of press if you follow this industry. The smart grid is, this is a new world of, how important is this data, how sensitive is this data, whose is the data. And it was important to us to make sure that the data kind of really belonged to the user, and they had as much control over it as, they had ultimate control over it. So one of the things that PowerMeter does is it makes sure that it always has your explicit consent before it accepts data about you, even if you're not sending us the data. So for example, if you have a utility, they know, how much power you've been using. They could send it to us, but we won't let them we won't store the data until you agree that we should store the data on your behalf. So that was an important part of our design of the system, and you'll see that in the kind of activation process that I'll talk about later. And then, of course, it goes the other way. You can sort of easily punch a button and say, please purge all this data. I don't want Google to keep track of it anymore. So we want to make sure everyone feels comfortable with this data and how we store it. Everything is authenticated. Everything is audited. There's no kind of anonymous or publicly published individual data feeds, so even though you can't tell whose data it is, we still don't let anyone have your data, whether they know that it's yours or not. It's just kind of an important part of keeping that data private and secure. Button. Yay, that worked. Security, of course, goes hand in hand with privacy. Our API is secured with auth_sub, which if you're familiar with other Google APIs, that it's a kind of token scheme that allows you to tie access to an API to a Google account. So it's sort of just as if you're logging into a web page, except for that you delegate that authorization to a computer so that it can use the API on your behalf. We secure everything with Google accounts, so the same account information that you might have set up for Gmail or for search preferences or for iGoogle, PowerMeter has that same account system, so there's no separate system to use. And when we integrate with a data provider, like a device or like a utility that's got your data and is sending it on your behalf, they can't find out who you are. They can't find out your email address that Google knows. They can't get your search history. They can't get anything about you. We obfuscate your ID with this kind of cryptographic key that we give them, and they tell us, they tie it to your account on their side, but they can't then use it to get any other information that Google has about you. So that's a kind of key part of keeping your personally identifiable information yours and private. I'm going to talk a little more detail about about personal identifying information in a second. This worked, yes. Okay, so now I'll go through sort of the storage model it's more than just storage, it's really the kind of the concepts that you can access with the API and the concepts that the PowerMeter manages and stores for you. At the simplest level, you have users. So everything is about the user and the user's data that gets uploaded from a variety of sources on your behalf. So I'm going to use my fancy new laser pointer here. You like the color? It's good. I ordered a smoke machine for this presentation, but it didn't come through. I don't know why. Anyway, so all of the data is stored associated with a particular user. PowerMeter cannot and will not receive any data unless it's marked for a particular person. So that way we can tell immediately when we receive the data whether or not that person has agreed to let us receive it, and we reject it right away if it's data that we don't have explicit consent for. So we have something called a zone, which you can think of as a writable silo inside of the user's kind of space within PowerMeter. And there's several different flavors of zone, which I'll go through in a second. But the first one is the user's own zone. We call it like a user zone or the personal zone. And if they have a device, such as an energy monitor that they installed themselves that's monitoring their whole house, or if they have like a plug sensor that's monitoring their entertainment system, or if they have a smart appliance that's sending in data about how much energy it's using, then all of those things kind of get authorized to operate on behalf of the user, and then they use the kind of token that I talked about before, which they get using the activation process, which I'll talk about in just a second. And they send that data into the user's kind of zone. And we store data in kind of data streams, which we call variables. It's just a kind of time-ordered list of measurements. So you can think of a variable as, you know, at noon, 1 kilowatt hour is used. At 1 o'clock, 1 kilowatt hour is used. At 2 o'clock, 2 kilowatt hours were used. So it's just a kind of very simple stream of measurements, and we put each of them in a variable. And users can have as many of those as they like. The other sort of major way that data can come into the system, again, always on behalf of a user, but within the user into a different zone, which might be created on behalf of a utility company rather than for the user's own devices. What's the same about the utilities zone is that the user can still access it and the data is still theirs. And if the user ever wants to kind of cancel their account, or if, of course, if they want to download the data, they can download or delete anything that's kind of in their part of their PowerMeter account. But if it's uploaded to the utility company's zone, then it's not modifiable in place. The user can only choose to kind of wipe it out wholesale, but they can't kind of twiddle it. So that keeps the data that was sent to us from a third party that already has a like secure meter data management system. It keeps the integrity of the data, even though it belongs to the user. It also kind of is in some sense valued by the utility. So the utility can send in data to these variables, and these variables look almost the same to the user, but they're secured very differently. One important sort of feature of zones is that the user can read across all of them, but the data providers can only read or write the zone that matches their own kind of identity. So the zone in this case is called the domain name of the company, which would be exampleutility.com in this example. Not actually a real utility, don't be fooled. And this company can read and write that zone, but nothing else. And then you can have more, you can have an unlimited number of zones. So if you have one utility company that aggregates and provides your data for electricity, and another one for solar, and another one for gas, you can just sort of stack all these guys up into your account, and they go into different zones. They can't interfere with each other. They can't read each other's zones. They can't write each other's data. So all the data kind of, the data integrity is preserved even though it's kind of all joined together. And the PowerMeter's security layer takes care of all that, which I made. So now I'll go into a little detail about the API, and we'll just kind of zing through this, and then we're going to have time for questions at the end, so if you have specific questions, I can kind of go back or answer questions for you. This is the API at a glance. It's a REST API, so like a lot of Google APIs or Google data APIs, it's based on Atom, which is kind of a concept of you have feeds, which are URIs, like just sort of a normal HTTP request, always secured in our case. We don't, as I said, security and privacy is very important to us, so it's pretty silly to allow data to be transferred in the clear over the wire. So everything is secured, HTTPS. Underneath the kind of top-level PowerMeter feed, there are feeds for a particular user, feeds for the user's variables, and then, which I mentioned are those kind of data streams of measurements. And then within each one of those, of course, the measurements themselves. You can write to measurement by doing an HTTP put or post to a particular measurement feed. or you can, oh, I don't have it on this slide, or you can use the, there's a batch feed, which essentially is a single URI, and you post a large number of XML blocks that describe 20 measurements or 1,000 measurements all at once. And we kind of process those as if you had hit this URL 100 times or 1,000 times. We just do it more efficiently, so you don't have to keep tearing down that connection over and over. I want to show you like these two parts of the API are the same system, but there's a slightly different naming scheme here. When you are acting on behalf of a user using their auth subtoken that they've given you, they've authorized you to use because you're a smart appliance or you're a thermostat or you're a home energy monitor, then you always work with the zone, which you'll see here is the third term of this URL path. And the zone for the user is just the user's own kind of obfuscated ID repeated. So you identify the personal zone by it's just the user's ID again. But if you're a utility, you upload to a different zone, which it matches your domain name. And when you hit the API as a utility, you use your own token so we can tell who you are. And then if you try to access a zone that's not yours, we give you the hand. And you can't access these kind of user zones either. So that's kind of how we maintain segmentation very efficiently. But otherwise, the API is the same. You still get variables inside the zone. You still post measurements using this kind of familiar REST, post, put, get API. I should say that you can get anything out of the API that you put into it as a data provider. So all of these feeds that you can post to, you can also get to, and there's query parameters, which are described in our documentation. And there's two flavors of measurements that we support, and I will go into a little more detail about those in a moment. But before that, I want to talk about how you get authorized to use the API. We have a kind of handshake process. As I mentioned, a core design principle of PowerMeter is that there's explicit consent at every step. So that means that we're not going to, if you say that you have some data on behalf of Joe user and you want to send it to us, well, we're not going to take it until we are convinced that Joe user actually wants you to send it to us on your behalf. So the way that happens is that there's a handshaking process which is done online. So it starts with Joe user using his web browser to go to either a utility company's website or a device. Devices can have their own web server. Or if you buy a device that's web enabled, you can go to the device's manufacturer to begin the process. The device manufacturer's website to begin the process. And essentially you say, begin enrolling, and then you come to PowerMeter where you see a cross-site attack proof web page that says, you are about to give your consent to receive data for PowerMeter. Are you sure this is what you want? And then when you say yes, the Joe user's browser will redirect back to whoever it is that's trying to get access, and that redirect is carrying the token that they need. So that's how that's how that handshake begins. And the user can break that connection anytime. There's a settings page in PowerMeter, so they can just see everyone they've given access to, and they can say, nope, delete all my data, or keep my data but deauthorize future uploads. So there's a lot of different options that we support. So we have kind of separate but similar handshakes for 3 different users of the API. So there's, oh, can I go back? Oh, I can go back. Come on, there. So there's one type of handshake for if you are a utility company and you want to get permission to write to this kind of separate zone. There's another type of handshake for if you are a device and you'd like to act on behalf of the user and write into their own zone. And then there's a third type of handshake, which we're working on now, coming soon, which will be if you want to read the API on behalf of a user. And that handshake will, yeah, here we go. And that handshake will support things like getting read-only access. So if you'd like to make a cool visualization app, the user shouldn't give you permission to write their data. You don't need that. So there's a separate process for getting a read-only access. The other thing I wanted to go over really quickly is abuse measures. If you use the API the way kind of our documentation describes, then you'll never find out that the system has quota and throttling, but it does. So we recommend that you kind of stay under our data rates, which are 6 data points per hour, so every 10 minutes you take a measurement and you can send it to us. And you can send it immediately. You don't have to delay it. You can do a immediate HTTP request to us as soon as you have the data. We also have a storage quota. Right now, at that data rate, we give everybody years of space. And we're raising it all the time just so that we make sure that we can stay ahead of the data need. As people send in more data, we want to be able to receive historical data. Not 50 years of historical data, but 3 years would be a fine amount of historical data to send us at maximum data resolution, which basically no one actually has. Like, utility companies are still kind of trying to get smart meters in place, and they've only had them for a little while. So there's very little very old high-resolution data out there. You can always send in low-resolution data, and of course that goes back many years, and we can receive that too. All the way back to 1970, I think. I can't imagine that it actually works if you send us data older than 1970. Anyway, the beginning of time, as it were. So as promised, I was going to mention in a little more detail the 2 flavors of measurement the PowerMeter can receive. We supported both of these flavors because different data providers have this data in different formats. So the 2 major ones are, first, if you think about how, you may not know how a power meter, an electricity meter works, like a really old one. It's kind of esoteric. But basically, all it's doing is it's just counting up at some rate, and there's a single number. There's just kind of kilowatt hours consumed since whatever, since it was installed or since it last rolled over to 10,000 or something like that. And it's just a single number, and it gets bigger and bigger and bigger. And what that number is doesn't matter. It's just the difference between that number and then the last time you measured it is what matters. So we can accept measurements that kind of are in this format. The way that works is you send us a time at which you got a reading. We call that the occur time. And then a value, which is the reading that you took. So the reading might be 236.24 kilowatt hours. And that number doesn't mean anything until you compare it to the measurement that happened like 1 hour later. And that 1 hour later might be 237.24 kilowatt hours. And that's how we deduce, over that hour, you used about 1 kilowatt hour. So we subtract them. So as you send us more and more occur time value tuples, we just kind of notice the difference between them, and that's what we infer the real measurement to be. And of course, as I said, the actual accumulator number doesn't matter, but if you ever need to reset it, like if it goes back to 0, or if you had a device that had an accumulator and it lost power and now you're starting over, you can send us this little marker, is initial, which just indicates this is a new accumulator value that doesn't have any relationship to the old one, so please don't think of it as a measurement from the last one. So this data format is better for if you're already going to build an accumulator, or if you already have a smart meter that sends data in this format. But it's actually relatively fragile for a number of reasons, because the measurements are all kind of interdependent, and if you kind of end up mishandling this little is initial marker, then you accidentally create huge spurious -2 million kilowatt like spikes in your data, which you don't want to do. So a more robust data format, given that we're using HTTPS to communicate with PowerMeter, that's over TCP. Those connections, like there's not packet loss. Like the data either always comes through or it always doesn't. And when it doesn't, you know that it doesn't. So this style of measurement is kind of designed to work with a lossy network, which utilities have, but that you don't have with us. So a better format is this one, which is we call them durational reads or interval reads. And you basically just send when you measured some time range. It's not a moment, it's a range of time. So you would say, for one measurement, you might say, from noon until 1, we measured 0.5 kilowatt hours. And that measurement is self-contained, and then we register that as, okay, that was a rate of usage over a period of time. And then you just send us more and more of those, and you can send them out of order, and you can backdate them, and you can overwrite them if you want. And that's how you express what you measured to us. And as I mentioned in the last slide, we have a batch upload feed, which you can see in our documentation, where if you don't want to just send us one measurement every 10 minutes, if you have utilities send us many measurements across many users each 10 minutes. So they will use our batch feed for that. And it's simply the same XML format, except that instead of closing a connection, you just send more of them. You can send up to 1,000, I think. And then, of course, we have feeds that give access to information about the user, information about the variable, information about providers. And then coming soon, we sort of call this the raw API, which is these are the measurements that you send us, and then you can get them back by querying that API, and you get back exactly those measurements. But a very common thing is you might send us measurements that are disjoint, right? So they might have gaps. You might send us measurements that aren't all the same length. Like a really common one is if you send measurements for every day, well, days don't always have 24 hours. There's daylight savings time and so on. So you can have kind of varying length measurements. And if you want to build something like charting, which it turns out we did, you don't really want that. It's kind of clumsy. So what you need instead is something that would like sort of smooth the data into a kind of fixed interval measurement, like you'd resample or reinterpolate the data. You might want to pull out features in the data, like notice the kind of always on or base load rate of usage. If you see a chart that's spiky, the level of usage that it never goes below, that's the kind of always on rate. You might want to pull out features like show me all the spikes in this data. So those are all examples of things that the PowerMeter computation engine is doing, and we're looking at exposing those back to you as an API so that you can use some of the calculations that PowerMeter is doing anyway. So when you go to sort of read data from PowerMeter, as I mentioned, we have kind of read-only tokens, which make it possible for users to authorize an application to visualize the data or read the data, but not to write the data, which that's not an access level that they want to give you. So it's a nice feature of the system that they can give you partial read-only access. Another type of partial access is what are called scopes. This is a kind of GData or an auth sub or OAuth concept, which is that you can say this token represents my access, but not to my entire account, only to this variable or only to this list of variables. So that's what you use token scopes for, and there's kind of details on that in our documentation. As I mentioned, we have this sort of GData API that gives raw access to the data. We have some Python programs that demonstrate how you use that raw API, both to write to it and to read from it. So we have a little Python program on our, if you check out code.google.com, that kind of pretends to be a device measuring electricity and sending data to us. And then sort of future APIs might have some of the things that I mentioned, like smoothing, charting, interesting feature analysis, et cetera. So those are all things that are kind of coming. Documentation links for your reference. We're on code.google.com under the APIs section. And we also have kind of we're a little bit different from other APIs in that oftentimes our API partners, like potentially you, are device manufacturers or utility companies or utility data aggregators or smart meter providers. So we have kind of a separate set of guidelines for how partners can work with us, and we have a kind of different package of documentation for that. So that's what you'll find here at this second link. That's all I had. If you have questions, we've got I won't blind you with this. We got microphones in the center of the aisle, so you can come on up and ask questions. And if not, then, oh, you do. All right.
You should probably go to the wave.
Oh. Srikanth knows how to work the wave, so I will let him do it.
Okay, let's go to live questions first.
Sorry, doing it the old-fashioned way. Thank you very much. I actually several questions and possibly even an offer. What about, you mentioned a lot about individual users. What about taking a community or a pool of users and being able to do work for energy reduction, for instance, in climate change calculations?
So there are a few different dimensions to how that could work. So one feature that we have today, for example, is a user who's got data on their behalf in the system already can sort of make friends, so they can share their data with other users. And so you can have a community of people that all have individual data, and they're all sharing it with each other. If you have a data stream that represents not data for a particular user, but data for an aggregate, like a whole town or like a school, is that what you're talking about?
Yeah, exactly.
Yeah, so you could send that data in to like a shared PowerMeter account. It would be analyzed as if it was for a particular person. So some of the visualizations that we have would be less appropriate for that. We have other ideas for how kind of communities can use PowerMeter. So for example, something that's coming soon is all the data that comes into PowerMeter is geotagged. So we know not exactly, but sort of to the city-state granularity, we know where it's all coming from. So it'll be easy for us to build kind of visualizations of like this group of people or this community that's near each other, kind of here's their data in total or how much they're saving, that kind of thing.
Well, I guess I'll just broaden this since no one's else in line. My name's Scott Bishke. I live in Bozeman, Montana, and I work with the Climate Change Task Force there.
Oh.
We have people on the task force that include public utility commissioners from the state. We have members, commissioner from the county, city staff. We have developers. We are the perfect test model for you guys.
Very good.
And we would love. We also have deployment of our climate change plan in about a year. We would love to be a test bed if we could come up with money to get smart meters into different places. And this is maybe the question for after. Can I talk with you afterwards? But
yeah, please. We're going to stay around a little bit after, so why don't you come on up and give us your card at the end, and we have business development guys who would love to talk to you.
Okay, thank you.
Sure, thank you.
I'd just like to thank the previous questioner. I represent another community in the building. No.
We can work with all of you.
I think there's great synergy here. We're actually located, it's a co-housing community being developed in downtown Mountain View, just at Calderon. So I'd like to talk to you about that.
Great, yeah.
But drilling down into the technicalities, there's a long history of distributed measurement and process control in heterogeneous systems like this of various extents. One of the issues is in being able to handle a large enough number of devices with a tractable device taxonomy to be useful, but not burdensome to capture the essence of the devices that are within the use cases. Maybe you could comment on your notion of device taxonomy, and then dropping down to issues that do relate to aggregation, namely issues of dimensionality of the measurements, units, precision, calibration, this kind of stuff that looks nice. The charts can look nice, but when you put error bars on them, things kind of go to hell.
Sure, sure. So the first part of your question was about taxonomy. So there, at a high level, we have a couple of different fields in the API that you can use that people are mostly not taking advantage of now. But the first thing that we care about is it consumption or isn't it? So there's kind of the notion of like, is it electricity in kilowatt hours? Is it solar generated in kilowatt hours? Is it gas? Is it water? Those sorts of things. So that's the kind of top level segmentation. Right now we only accept electricity data, but it's trivial for us to extend the platform to accept other kinds of data. Within electricity, trivial for us to accept and store. I should clarify that one of the reasons why we haven't is because the way that you define the user experience and the way you do the analysis around something that's not electricity is very different. So it's like, yes, it's all measurements, so that's easy to store, but if you want to show it in an interesting way, show gas in an interesting way, we should think more carefully about that than just be like, slap it on a chart and say like, this is just like electricity, but in therms. It's not like, that's not the right way to show it. So drilling down into, once we know that it's kind of electricity, is it consumption or is it not, then the other main kind of pivot point is this kind of whole home, or is this kind of a particular device giving us only a portion of like a narrowly disaggregated read? So that's the next kind of major piece of the taxonomy that we care about is if it's whole home, then we know that it's a very noisy data stream that's got lots of interesting stuff in it, and it's worth applying computational heuristics to try to pull artifacts out of that. But if we know that it's just one device data stream, like it's just a TV or just an air conditioner or just a washing machine or something, then we treat that data very differently. Beyond that, you can imagine a taxonomy of appliances or smart cars or thermostat uploads or something like that. And we have kind of a first crack at that with we're planning to offer kind of a user-definable field. That's not available yet in the API, but that'll be kind of an extra level. But so at that level of detail, the API is still kind of forming. Does that speak to your question?
Yeah.
Okay. The second thing you asked was? Give me aggregation, right.
Or disaggregation, yeah.
The API supports an uncertainty field for every value you send. You can also send a kind of error bar. It's not defined what that means, but it's not a standard deviation. It's like a min-max variance. And then the units are defined. You upload the unit with every measurement, and then the unit is always an SI unit in this specific way that you express it. So it's like kilowatt hours is like lowercase k, big W, space H, and that's like how we parse the units. So we carefully track the units, and if you send us different units, then we convert them if they're convertible and give you an error if they're not convertible, that kind of thing.
Okay.
Actually, one other. So what we're doing is going to have a very sustainable community, and we're going to take on the automobile as well. So.
Okay.
Great. Thanks.
Thanks.
Yeah, so I had a question about when everyone in the world is hooked up to Google PowerMeter, how are you going to handle the network bandwidth? Every 15 minutes, that's a lot of data, and it comes very rapidly. And then the other thing is, when people want to change their behavior, it's more effective if you give them the data, the feedback in real time, like you turn the light switch on and you see the curve going up, but you have quite a delay in there. It's not real time, right? It's just graphing what exists from the past.
Right. So those are both good points. First, about bandwidth as we get more users. It's something we say internally in the team is that we are excited to have that problem. There are a lot more efficient ways to handle a lot of kind of near real-time data than doing like HTTP, open TCP connection, open SSL connection, send like verbose thing of XML, close, start over, right? Like it's really wasteful. So XMPP is a way that you can stream data. So it's more efficient for on the wire in exchange for more kind of state on either end. So that's a trade-off that we could make where we could like buy network using CPU. I'm not worried about this. One of the reasons why the data rate is as low as it is, which is every measurements every 10 minutes, is that with that measurement we can easily scale up to a couple million people, and then the plan is to kind of move to a higher bandwidth API that's more efficient and not XML based when we kind of get to that level. But the smart grid data is ramping up pretty slowly, so we have some runway. The second part of your question was real time. So as I mentioned, you could use kind of like other alternative data formats like transport mechanisms like XMPP to make real time data much more efficient. The other thing that I think is important is it is true that the kind of Prius Effect research that's been done to date is about real-time feedback, but that's not the only way that you can save. One of the things we've noticed with PowerMeter, for example, is it's common for devices to have a little panel in your house where, like, if you're in your house and if you're looking at it, and if you do some action and then that action has some obvious effect on the panel, then you get that real-time feedback. But PowerMeter is a historical store, right? So like we are storing all this historical data, and we can analyze it over longer-term trends. So not every savings opportunity only comes from real time. There are a lot of savings opportunities that come from noticing patterns over time, and PowerMeter does that.
So my utility does not partner with you currently, but they do provide their own little website, and you can download the CSV files. So I'd like to
Sorry, what was the name again?
My name is Andrew.
Oh.
And my electric company is PG&E.
Oh, right.
So what I'd like to do is just parse the CSV file and then upload it to you, and then I can view it from my Google. What are the barriers to that? Are there? Can I do that?
None. So in fact, if you download our client library, you'll see an example of, and in fact, even in the developer forum that we have, there are people who are starting to play with things like that, where explore. But we do have a very simple API example in the Python script that is a pretty easy to use thing. The one thing you have to be careful about is you will have to do this authentication process. So that is something that you'll have to, you may have to build a simple web app for it, where you essentially generate a token, but that should be not that complicated. But it is technically feasible. Right. And the developer forum has examples, and there are a couple of people who have built like a C# library, and they've also done where they're storing data locally in a MySQL database and then sending it through a CSV, generating a CSV upload and sending it to us, and that's working, I would say, well.
Yeah. It'd probably be cleaner if you worked with the Python library, but you could actually use the sample Python code just with sed and pipe, and then it would work.
Thank you.
Sure, thank you.
I came in a little late, but I gather you have general power use measurements and power production case for solar panels, but you also allow, for the future anyway, just specific devices to upload data? Okay, so just an idea would be also a type of measurement to take would be amount of sun hitting solar panels. So are the solar panels dirty or not? You can't tell by the amount of power they're producing whether they're dirty because you don't know what the weather's like. So you'd have to measure the sunlight.
Yeah.
So that'd be kind of thing to.
There's
a kind of data to upload.
Yeah. There's a set of ancillary data streams when you do measurements with using inductive CT clamps, or if you are assessing the kind of useful efficacy of your solar installation, there's you want to look at kind of voltage, and then another metric like this, which would be you want to look at temperature, you want to look at sunlight, and we as I was mentioning before, we do not currently accept measurement types other than electricity, but we easily could. So that's kind of something that we'll be looking at as we integrate solar.
Because you can look at the weather map, but that doesn't account for the trees at a particular place or something. You have to actually
Yes, in fact, just an example of this is not my data, but one of our team members has a solar panel in their house. And so we recently allowed people to send us data. So this is generation data. And it's very useful for people who have solar panels to understand, am I producing the electricity as I'm expected to produce? So it's starting to give us good sense for, is something occluding it, et cetera, et cetera. So it's definitely starting to kind of help diagnose and get there. So. Last one in, then we have to get to the wave ones also. So yeah.
Hi, I'm actually on the wave. My name's Jorge Ortiz. I'm from UC Berkeley.
Okay. Oh, great. Two birds with one stone.
I was wondering if there's a way to create a virtual meter. Say you collect the data that I have a bunch of meters in my house that are all publishing to Google, and then I can create a process that collects that data and then makes that available, a digest of it available to someone that I can share it with or something, so effectively a virtual meter.
So you'll have to do the aggregation externally for now, but we are trying to, as we are exploring ways to go beyond just whole house or device appliances and individual streams we also have ways to do the aggregation, but for now you'll have to do the aggregation outside and send it as one variable or data stream.
Okay, so would the virtual meter then look like any other one of my meters that I would
It'll
have
be
in
an
my
aggregated
house?
view of all the meters.
Sure.
That you see, yeah.
Okay.
So in fact, we have a device partner that sells individual plug level devices, but what they do is they have the individual plugs all streaming data to their servers first, where they aggregate it and they send one consolidated stream.
Okay.
But they also have the individual streams in addition to that. So if they want to diagnose, that's also feasible. So let's quickly jump into some of the questions on the wave. What incentives do utilities have? It's an excellent question, and we're trying very, very hard to make utilities understand what value we provide. I think the biggest value proposition is customer engagement. I have almost never gone to the website that I think one of the audience members mentioned on looking at like how much I'm using. I would love to be able to get to this data without any effort. I'm not going to make the effort to go to another website. If it is something that I can get to as part of doing my search or doing the other activities on a day-to-day basis, that's useful to me. Utilities do need this way to connect to the customers, and we feel like this is an easy, low-cost, almost no-cost effort on their part to be able to connect up with the users. So we think that's a huge value proposition, and especially as the smart grid rollout goes out, there is a lot of complexity that is on the horizon. Like we're talking about time of use pricing, we're talking about more sophisticated controls. A lot of it can be made more user-friendly if you're able to show the people the data before they start seeing the impact of it. So we feel education and engagement is probably a key value proposition. How have utilities imposed restrictions on data sharing? So data, again, our fundamental philosophy is data is the user's data. While the utility is collecting it, once the user is given permission to give it into PowerMeter, it is the user's data, and they control who has access to it. So when I'm sharing my data, I'm not taking anybody's permission. I'm essentially exposing it from my perspective. So at this point, there are no restrictions, but clearly this is a pretty delicate topic, and especially as some of the discussions on how does smart grid rollouts go out, it might obviously be influenced. We are very, very active on the policy front also, in addition to obviously building the product. I would say a third of our energy goes in just working with the policy and the federal programs that are out there, which are trying to lay the standards and the groundwork on this. So things will change, and we'll stay up with it. But we do at this point very strongly feel, and our fundamental philosophy as the user should decide what happens with the data, and they should drive it going forward. How much control does the API give me over granularity of data sharing? Right now, it's all or nothing. You can't, when you share, I shared, so when Russ shared, he shared all of his data with me. Likewise, when I share my data, all of my data, so all my variables get shared. We are trying to see whether people find it more interesting to be able to share parts of it, but that's, again, it should be a filtering process, which should not be that hard to implement, but it's not currently supported. Prerequisites in the Bay Area. Unfortunately, the options in the Bay Area are to kind of look at home energy management devices, but there are a slew of those coming in the market, a lot of very innovative startups in the space which are trying to do creative applications. Some of you, if you're interested, we just about a couple of days back, Tweetawatt, which is a variation of Kilowatt. The couple of developers have built out like a very easy integration. So if you have a Tweetawatt device, you can pretty much get like a $50, $60 device and get it to kind of talk to PowerMeter. So, and there are more coming in on the horizon. In terms of utilities, we are actively pursuing having more utilities work with us, but clearly it's a complex space to navigate and work with. So we're hoping we'll get more utilities with us, but it'll take time to get there.
And PG&E specifically, we're always talking to them, and we're continuing to learn about the barriers on their side to adopting.
We're trying hard. So, all right, and I think we already answered the last one. So if there are no other questions, we'll be around to continue chatting and take it from there. Thanks, everyone.
Thanks.